Hi guys, may adlaw. For today's video, I will be presenting to you about graphing logarithmic functions. For the objectives, at the end of this video, you should be able to sketch the graph of a logarithmic function. Number 2, you should be able to find the domain and range of a logarithmic function. This lesson requires us to have a prior knowledge on the following. Number 1, definition of exponential function. Number 2, graph of the exponential function. And number 3, the definition of an inverse function. Because logarithmic function is just related to exponential function and inverse function. We've got to remember that logarithmic function is just an inverse function for exponential function. Let us compare first the exponential form to logarithmic form, or exponential function to logarithmic function, in terms of the general form, the domain, the range, the translated form, and the asymptote. The general form for the exponential function is y equals b raised to x, while the general form for logarithmic function is y equals log of x base b. Now, the domain, we already have discussed about the domain and range of exponential function is defined by negative infinity up to positive infinity. The domain of the exponential function is from negative infinity to positive infinity, and the range of the exponential function is from 0 up to positive infinity. Whereas, since I have mentioned here that logarithmic function is just an inverse of exponential function, so what will happen to the domain and range? When we say inverse, the domain of the function or the domain and range of the function shall be reversed, meaning the domain of exponential becomes the range of the logarithmic, and the range of the exponential becomes the domain of the logarithmic. So meaning the domain of the logarithmic function becomes from 0 to positive infinity, and that is the range of the exponential function. And the range of the logarithmic function, of course, shall be negative infinity to positive infinity. Because, as I have said, these two functions are inverse functions. Of course, if they are inverse, so therefore the domain and range shall also be reverse. The translated form for exponential function is defined by y equals a times b raised to x minus h plus k, wherein h is the horizontal translation and k is the vertical translation. While for the logarithmic form, we have y equals a log of x minus h plus k to the base b. And of course, since they are again inverses, the asymptote for exponential function is we have horizontal asymptote, while for the logarithmic, we have the vertical asymptote. Okay, let's proceed to the graph. The graphs below illustrates the graph of exponential and logarithmic function as inverses. So for example, if we have this Partition plane, of course, we will illustrate first the line of symmetry because we are going to graph an inverse function. In an inverse function, the line of symmetry is always present. Okay? So if this is the line of symmetry, we are going to plot the graph of exponential function. We all know that the graph of exponential function shall always pass through the point 0, 1. Okay? Through the point 0, 1. And if I have to choose another point, if I have to choose this point here and connect these 2 points by a curved line, so this is now our graph for exponential function, given the general form. Since logarithmic is just an inverse, so we get the inverse of 0, 1, that means 1, 0. So this is now our first point, and this is now our second point. Connect that by a curved line. These are now the two graphs for exponential and logarithmic. This graph is for y equals b raised to x, and this graph is for y equals log of x base b. So this graph is the graph for exponential, and this graph here is the graph for the logarithmic. These two functions or these two graphs are defined by the general form, illustrated in one Cartesian plane to indicate that these two functions are inverses. So how do we plot the graph of a logarithmic function? So let's start with example number 1. For example, we are to plot the graph of y equals log of x base 3. As you can see, this form is in general form for logarithmic function. We have the y, we have the x, we have the base here. Now, the first things first, we have the Cartesian plane. If we want to sketch the graph of a logarithmic function, we need to equate. First is we need to equate this value here for x to three values. Number 1, equate to 0 for the vertical asymptote because x here should be greater than 0. Meaning, if we are going to equate x to 0, that means that 0 is not part of the solution because x should always be greater than 0. So first things first is equate to 0. Next is to equate to 1. And next is equate to whatever is the base. So we have x equals 0 for the vertical asymptotes. Another is x equals 1 for the first point and x equals 3 for the second point. So later you will understand how do we go over with these points here. For the table of values, we have 1, 3. Then how did we get 0 and 1? Okay, check. 1 and 3 is from this point here, from this value here, x equals 1 and x equals 3. We did not include x equals 0 because this is for vertical asymptote, meaning 0 is not part of the solution. 0 is not part of the domain. 0 is not part of the domain for this function. So we only have 3, and for this example, for this table of values, we only choose 3 and 1. Why do we need to use 1, 1, and 3? It's because when we substitute 1 to x here, we will have y equals log of 1 base 3. Log of 1 to whatever is the base is always equal to 0. Again, log of 1, any base or whatever the value of the base is always equal to 0. So meaning, if this is 1, everything becomes 0. That's why we have 1 as the x and y as the 0 because this becomes y equals 0. Everything becomes 0. That's the purpose why we need to equate x to 1. Another is we have the 3. If we are going to substitute 3 here, that becomes y equals log of 3 base 3. Now, if the value here is equal to the base, if the base and this value here is equal, that goes to follow that the whole logarithmic function or the whole logarithmic expression is always equal to 1. That's why we have y equals 1. So everything becomes 1 if they are equal. That's why we choose 1 and 3 as the value for as the chosen domain for this specific example. So these are now the two ordered pairs that we need to plot in the Cartesian plane. But first things first is we need to plot the vertical asymptote first, that is x equals 0. So this time we have this line, the y-axis, as our vertical asymptote. Then we have 1 and 0, so this is 1 and 0, first point. And another point is 3 and 1, so this is the second point. The next is to connect these 2 points by a curved line. Now, this is now the graph of the function y equals log of x base 3. As you can see, as I've said, this expression or this function is in general form. That's why our graph cross at the point, intersect the point 1 and 0. And our vertical asymptote is our y-axis or the x equals 0. Now you have to remember that this graph goes down infinitely. So I just do not have the arrow here, but it is assumed that this graph shall go down infinitely. So if we are going to identify the domain of this function, of course, from this point here or from this line here, which is our line x equals 0, towards the right to positive infinity, excluding 0. That's why the domain shall be 0 to positive infinity. And of course, our range is the same from negative infinity to positive infinity. I just want to remind that every logarithmic function has the same range from negative infinity up to positive infinity. Only the domain shall change. Okay, let's proceed to example number 2. For example, we are given this function. Y equals log of x plus 2 base 3 minus 3. This time, we have these inner terms, x plus 2. The first example, we only have the x. This time, we have x plus 2. So we need to choose, again, we need to choose at least 3 points. Number 1, equate these inner terms to 0 for the vertical asymptote. Next is equate to 1 for the first point, and another is equate to whatever is the base. In this case, the base is 3, so we need to equate x plus 2 to 3. So first is x plus 2 equate to 0. That is for the vertical asymptote. So by subtraction property, we will have x equals negative 2 by subtraction property. So this is for our vertical asymptote. So therefore, our vertical asymptote shall be negative 2. So this line here, negative 2. Now next is to equate x plus 2 to 1. Excluding, do not include negative 3 because it is not part of the inner terms here. So we have x plus 2 equate to 1. Then the same, we use subtraction property. So that is x equals 1 minus 2. Therefore, our x is negative 1. Next is equate to whatever is the base. In this case, our base is 3. So we equate that to 3. The same, we use subtraction property. So we have x is equal to 3 minus 2. So 3 minus 2 is 1. So our x is 1. For the table of values, we will have here excluding 0. So 0 is not part of the table of values because, as I've said, 0 is not part of the domain. That is only the restriction in the graph. So we start with x equals negative 1 and x equals positive 1. So we have here negative 1 and positive 1. Now, how did we get negative 3 and negative 2? We will substitute x equals negative 1 to the function. So for example, we have log of the given x plus 2. So instead of writing x here, we change x with negative 1 because our x is negative 1. We change that with negative 1. We copy plus 2, we copy minus 3, we copy the base 3. This time we simplify this part here. So we have y equals negative 1 plus 2 is 1. Then copy log base 3 and minus 3. Now, as I've said, log of 1 is always equal to 0. Log of 1, whatever is the base, is always equal to 0. So, bisag unsa pay base ana, basta 1 siya, this is always equal to 0. So, this becomes y equals 0 minus 3. This is our 3, which is simply copy 3. So, therefore, y is equal to negative 3. So, we have here negative 3. Now, how did we get negative 2? The same. We substitute 1 to the function, so we will have y equals log of, instead of writing x, we change that with positive 1. So 1 plus 2 is 3. So we have y equals log of 3 base 3, then we copy minus 3. So I've said, if the value here is equal to the base, if these two are equal, so that will make the whole logarithmic expression equal to 1. So therefore, everything here becomes 1 except the minus 3. So we will have y equals 1. So everything here is 1 because this number is equal to the base. So this is 1. Then we copy minus 3. So 1 minus 3 is just equal to negative 2. Now let's plot the points. Plot first the vertical asymptote. So we have x equals negative 2. So this is our vertical asymptote. The red broken line here. Then plot the first point, negative 1 and negative 3. So this is our negative 1 and this is our negative 3. So this is our first point. Next is plot the second point, 1 and negative 2. So this is our 1 and this is our negative 2. Then connect these 2 points by a curved line. This is now the graph of the function y equals log of x plus 2 base 3 minus 3. Now for the domain, so we have our domain shall start from negative 2 up to positive infinity, but excluding negative 2 because this is our vertical asymptote. Our graph will not cross this line here. It will just move closer to this line but will not cross this line. That's why this is not part of the domain. Our graph will move downward infinitely and will move to the right and up infinity. So therefore, our range is the same as it is true to all logarithmic functions. The range will start from negative infinity to positive infinity. Okay, let's proceed to the last example. So how do we arrive at this table of values here? We have 0, 4 for x and we have 2, 1 for y. For example, we are given this function. Y equals 2 minus log of x plus 1 base 5. So we have here the value x plus 1. We need to equate this one again into 3 values. Number 1, equate to 0, equate to 1, and equate to whatever is the base. In this case, our base is 5, so meaning we will equate this one to 5. Therefore, we have x plus 1 equate to 0 for the vertical asymptote. Now we have to use subtraction property. This becomes x equals negative 1. Therefore, our vertical asymptote for this function is the line x equals negative 1. Next, equate x plus 1 to 1. So we have x plus 1 equals 1. Subtraction property, that becomes x equals 1 minus 1. So therefore, x equals 0. That's why we have the 0 here. Another is equate to 5 because our base is 5. So x plus 1 equals 5. Again, subtraction property, we have x equals 5 minus 1, which is equal to 4. So that's why we have the 4 here. So how do we get 2 and 1 for the y? We will substitute these values 0 and 4 to the function. So that's why we have y equals 2 minus the x here. Instead of writing x, we change that with our value 0 here. So that's why we have 0 plus 1. So 0 plus 1 is of course 1. So we will have y equals 2 minus log of 1 base 5. Then again, the log of 1, regardless of the base, shall always be equal to 0. That's why we have y equals 2 minus 0. Then, therefore, y equals 2. That's why if our x is 0, our y is 2. Now, how did we get 1? So we have substitute to the function 4. Y equals 2 minus log of 4 plus 1. So instead of writing x here, we change that with 4 because our x here is 4. 4 plus 1 is 5. So we have y equals, we copy 2 minus log of 5 base 5. Then the same value, the value here is equal to the base, which is 5. So that will make the whole logarithmic expression equal to 1. So that's why we have y equals 2 minus 1. So therefore, y equals 1. So we have 1 here. These are now the two ordered pairs that we need to plot in the Cartesian plane. We already have the vertical asymptote, which is negative 1, x equals negative 1. Plot the first point, 0, 2. So this is 0 and 2. Ward, we have the first point. Then the second point is 4 and 1. So we have here 4 and 1. Then connect these points by a curved line. This is now our graph of our logarithmic function. So as you can see, our graph moves upward, infinitely upward, and of course, infinitely to the right and downward. So for the domain, our domain will start from negative 1 up to positive infinity, of course, excluding negative 1 because our graph will not cross negative 1 because this is our vertical asymptote. And the same for our range is from negative infinity to positive infinity. So that's it. I hope you have learned something from this video. Before I will end this video, let us have first this practice exercise. Try to sketch the graph and find the domain and range of the following logarithmic functions here. So we have 4. Try plotting the graph of these functions, then refer to the examples that I had presented earlier. Before I end this video, I want to leave this quote. Mathematics is not about numbers, equations, or algorithms. It is about understanding. This is by William Thurston. So thank you and God bless.